This is lesson 3 for Unit 1 in Chemistry 2, Intermolecular Forces. This is video 1, and in this video, we're going to talk about the energy changes that accompany phase changes. And we're going to name those phase changes and go over what is actually happening in these. So, this arrow over here on the side is going to represent energy contained or energy added. So, as we go up from a solid to a liquid to a gas, we're going to end up with a change in energy. So a gas contains more energy than a liquid, and a liquid has more than a solid. So we're going to follow the arrow. So if we're going from a gas to a liquid, that process is called condensing. So condensation or condensing. And because liquids have less energy than contained with a gas, the energy in going from gas to a liquid is going to be exothermic. So if you remember in Chem 1, exothermic was a release of heat. So heat is given off as a gas goes to a liquid. If we go from a liquid to a solid and follow this arrow down, this is the process of freezing. It too is exothermic. Now, if we follow the arrows and go in the opposite direction, solid to liquid is melting. And that process is endothermic. It requires energy, so you have to heat up a solid to get it to a liquid. And if we keep on adding heat to it, we end up turning the liquid into a gas, and this can be evaporation, boiling, if we are adding heat to it, or we could even say vaporization. So any of those terms, especially boiling and vaporization, are kind of interchangeable, but these are all endothermic also. And you'll notice that the space is different. That's because it takes a lot more energy to change a liquid into a gas than it does a solid to a liquid. And we're going to quantify that later. So this is just qualitative amounts. And then we can go, some things go directly between a solid and a gas, and vice versa. So if we are changing a solid into a gas, that is called subliming. Some things do that readily, like solid carbon dioxide does not go through a liquid phase, it goes directly to gas. This is also endothermic. If we go in the opposite direction, this is called depositing. It's exothermic. So a gas directly to a solid. Now the big thing here is, I don't know if I have it on the back, I do not, but we'll write it right down here at the bottom. During a phase change, temperature stays the same. So if we take a solid and we're heating up the solid to, let's say that we have ice at 0 degrees and we're going to water at 0 degrees. In order to reach 0 degrees, we have to add energy to the solid. Once we hit 0 degrees, the energy that is added is used to break intermolecular forces. So the temperature is going to stay the same until all of the ice has turned into liquid. So the temperature stays the same until the change is complete. Energy added or removed, released, however you want to say it, is used to break or form intermolecular forces. So if we're adding energy in, remember that energy equals speeding up the molecules. They move further apart. The intermolecular forces are weaker, so it's easier to break apart as you add more energy. We end up with endothermic, either melting, boiling, whatever. If we're going in the opposite direction, if we're cooling down a gas, we're slowing down the molecules. It allows them to get a little bit closer together, and those intermolecular forces of attraction can actually hold on to one another a little bit better, and it clumps things together. So if it's a gas going to a liquid, it will just bind them together a little bit more. They can still slide past one another, but not as much as they did with the gas because we're slowing the molecules down. So our next video is going to be quantifying these phase changes and putting values to them.